Band structure with GW and Plasmon pole method tutorial. Create a simulation, by navigating to the Job Designer page. Then, open the Materials tab, and choose a 2D monolayer film of boron nitride as the main simulation material structure, by selecting it in the list. Then, open the Workflow tab, and choose the Plasmon pole GW band structure workflow by selecting it in the list. We first need to remember to change the size of the plane wave and charge density cutoffs under Important Settings, and increase them for improved accuracy. Similarly, we also modify the size of the grids of K points and of Q points, for the case of both units in the workflow. The z-dimension of such grids can be left to 1, since we are dealing with a 2D material in this case. Finally, we make sure that the path of Q points in reciprocal space over which the band structure is calculated is reduced to the gamma-m path only. It is worth highlighting that such GW computations performed with Quantum ESPRESSO need to be implemented with norm-conserving pseudopotentials. We now inspect the structure of the GW workflow, by opening its main GW compute unit. The user will find at the bottom the input script for the SternheimerGW code. This code is needed by Quantum ESPRESSO to implement the GW approximation via the GW needs Plasmon pole model, by obtaining quasiparticle energies using the wave functions and charge density of the previous SCF calculation. After that, navigate to Compute tab, and set Compute configuration. Here, we use one node with 8 cores on the OR8Q. Care also needs to be taken in this case to set the K-point pools parallelization setting under the Advanced Options to 8 as well, in order to run the SternheimerGW code in parallel. Then, set the name for the job. Here, we call it BNGW Plasmon pole band structure calculation. Next, save the job. It can then be selected and submitted to the compute queue, for execution. The status of the calculation will change from pre-submitted to submitted, and then to active. Please wait until the job has finished running. When the job is finished, open it to inspect the final results. The electronic band structure dispersion plot of the boron nitride film, obtained via the GW approximation, can be found towards the bottom of the results page. This final result is in agreement with the published literature, together with the resulting estimate for the size of the indirect band gap of boron nitride. This completes the present tutorial.